So we talked a little bit about interference already when two waves pass through one another. The last thing we want to look at is kind of if we have sort of 2 point source waves. So I have these 2 water waves here. So you can kind of tap your fingers and you'll generate those waves that are propagating out in concentric circles. What we're interested in looking at is when they start to overlap one another. So you'll kind of see these white spots here and you'll see these dark spots. So these dark spots are going to represent areas of destructive interference. These kind of white spots here, they're going to represent areas of constructive interference. So where we have constructive interference, this is where the 2 waves are going to overlap, like crest meets crest or trough meets trough. And the black spots here, this is going to be where one crest meets a trough or one trough meets a crest. So this is what we refer to as an interference pattern. Now I'm just going to kind of go over very briefly of what we can expect or what you need to know from these interference patterns. This is something that we will study way more in depth in Physics 30, so this is just to kind of give you a taste of what's going on. Now, you'll see this sketch. You'll see this interference pattern, so we're just sketching the crest with these blue or these green lines. And you'll notice I've drawn, or these other lines are drawn like this P1, Q1, and R1. Now, let's look at P1. At P1, if we draw that line it's directly between the 2 sources, so like where we've generated the waves, like say we tapped our fingers. So that line's directly between the center, and it's going to cut through the wave. What you'll notice is that no matter where on that wave you're looking, you're always going to end up at constructive interference. You're always going to have a crest meeting with a crest or a trough meeting with a trough. So this line here is what we refer to as the central maximum. So in the central maximum, this is where we're going to have complete constructive interference all the time. So that's good to know. The other thing we should note on the central maximum, if I look at the distance from source 1, so like where this wave starts, like if I take the distance from here to here, and I take the distance from source 2, so I'll call this D1 and D2, D1 is going to be equal to D2. That difference between them, or sorry, they're equal, like the distance to go from here to here is going to be the same as from here to here. Or we could say that that difference between them is 0. That's going to be really important later. You'll notice that this second line here, this Q1, how it's drawn, you'll notice that wherever you look, you'll notice that here at this point, for example, we have a crest of one wave meeting the trough of another, because the trough is that line in the middle of the 2 crests. Here we have a crest meeting the trough of this wave. So no matter where we look on this line, we're going to have destructive interference. We're always going to have the crest of one wave meeting the trough of another. So first of all, there's destructive interference. You'll also notice, and it's crammed on this diagram, you'll notice that this distance from S1 to some point on this line, they've labeled that as 5 lambda. Don't worry so much about the number. That's not the important part. And then the distance from source 2 to that point is 4.5 lambda. So for that, the difference, 5 lambda minus 4.5, is going to be half lambda, or half of a wavelength. The numbers aren't important, but that difference is. So what we're going to find is on this line of this first line of destructive interference, this difference we'll call in path length, so the distance to go from the source to this point on the line, and between this source and this point on the line, it's going to be half of a wavelength. And we're going to come back to that in a moment. Now, if I go to this next line here, this R1, so no matter where we go on this line, we're going to have crest meeting crest and trough meeting trough. So we're always going to have constructive interference on this line. So the distances that we are given here is we are going to be told that on this line here, or this point, the distance from S1 to that point is going to be 5 lambda, and then the distance from this source to this point is going to be 4 lambda. So we could say that the difference here, 5 minus 4, is 1 lambda. That is also another important distinction that we want to make. Now you might ask, okay, why are we looking at all this? So again, this line here that's cutting right through the center is what we call the central maximum. This line here is what we call the first order minimum, where we have the destructive interference. And then when we start to have all these maxima again, this is what we call the first order maximum. So what we're going to notice is we're going to notice these conditions. So like this kind of explains what we were just talking about. This is what's really important for Physics 30. is these conditions to have maxima and minima. So where we have constructive interference, this is sometimes referred to as maxima. Where we have minima, these are what we refer to as destructive interference. So if we want to have constructive interference to occur, we need that difference in the path lengths. So like these path lengths that we've drawn here, if there's constructive interference, we need that path length to be some integer multiple of the wavelength. So there has to be no difference, 1 lambda, 2 lambda, which is what we found on that diagram. The actual path lengths themselves, we didn't care about. It's that difference between them. So if the difference between the path lengths from the two sources is an integer multiple of the wavelength, we will have constructive interference. If that path length happens to be, if we want destructive interference, we're going to have an odd number of half integer wavelengths. So that difference in path length has to be like half lambda, 3 halves lambda, 5 halves lambda. And we found for our first, so for this line of minimas or destructive interference, we found that this path length had a difference of half a wavelength. If you went to the next successive destructive line, you'd find it's 3 halves of a wavelength, so on and so forth. This is the important part for Physics 30. If you want constructive interference, you need that difference in path to be an integer multiple of the wavelength or nothing at all. If you would like destructive interference, you need that difference to be a half integer multiple of the wavelength. So not something to worry too much about for Physics 30 or for Physics 20, but this will become more important when we study things like diffraction and Young's double slit experiment in Physics 30.